routines that provide students with meaningful practice with computation, mental math, mathematical relationships. They're a great tool to help our students develop computational fluency, identify multiple strategies in which to solve problems, and to think and reason like mathematicians. So I'm going to have her kick this off and introduce students. And I also probably should recognize Connie Hitchin, Forest Hills principal, sitting back in the back there, proudly looking on. So with that, if you want to have students introduce themselves, or you want to introduce them, and get going.
I'm Pranav. I'm Eva. I'm Julian. I'm Lila. I'm Cole. I'm Jillian. I'm Arjun.
And I'm Mrs. Kale. And this is really like, I speak in front of 24 people every day, but it's not you, it's them. So I'm just going to pretend you're all not here. And guys, turn your chairs and wheel them this way so that you can participate in the number talk in a positive way. So one of the great things about number talks, I've been doing these for probably 7 years, and I started out really strict following a curriculum that was provided for me. And what I realized as I did more research and I read about them and I practiced them with students is it's really about being a divergent and flexible thinker and using a lot of mental math. And the best thing about a number talk is it's not tied to curriculum we're doing. It comes from outside sources and ideas. And so today we're going to start with a pretty basic number talk. They all involve 100% of mental math. The students are required to speak clearly and articulate their thinking while I record their thinking. And so they have to really think about what they're saying to make sure it makes sense to others. And here comes Ikram. All right, so we're going to solve a multi-number equation. So as you're thinking about it, 5th graders, fist on your chest. Give me a thumbs up when you have one way to solve your problem. Other ideas?
Okay, so first I did 4 minus 3 and I got 1. And then I did a plus 2 equals 10. And then I added those together. And I got 11. Then I did 11 minus 10 equals 1.
I saw you agree number. Is that how you did it? Yeah, 11 is different. You want to share your thinking for us?
So first, like I did 4 minus 3 and it's 1, and then I added plus 8, which is 9, and then I added a 2, which got me 11, and then I did minus 10, which I got 1.
Awesome. So 2 different ways. Do we have a third way?
So first I did a plus 2, which is 10. Then I did 10 minus 10 is 0. Then I knew 4 minus 3 is 1, and I got 1 is my final answer.
So number talks usually take anywhere between 5 to 10 minutes. We would probably look for more connections and find another way, but I want you to see a little bit of the variety of what we do. So I have another one, and this is requiring crowd participation. So you don't have to answer with the microphone, but if you hear an idea you like, you can do the me too, which we do. That was my thinking. Which one doesn't belong?
Uh, 1/20th, because all the other fractions are not unifractions, and 1/20th is a unifraction.
Anyone? You have a different idea?
5/4 is an improper fraction.
Anybody with another one?
I think 20 by 25th because like it doesn't fit like rest of the numbers because it doesn't like so like 3 and 4 don't fit with 25 even with 22.
Tell me
20.
a little bit more. So you're saying 20 and 25, that numerator and that denominator. Keep going. Tell me about that. Are they both multiples of the same number? Is that what you're saying?
No, like I don't think they're like the same number. Like 25th doesn't like work with the other numbers.
Tell me why 25th doesn't work with the other numbers.
It's because like it doesn't have like a number of like 5 or something. Like because I checked the denominators for any sign 25 and it thought that it doesn't fit with the rest of the numbers.
So 20/25 doesn't work because of the denominator of 25.
Yes.
Can anybody think of another reason 20/25 might not work? Okay, you can take one. It's on.
I think 2/3 is one of them that's not in the fractions because it's the biggest one and yeah. And
So each month I introduce a new way of thinking. So the next one they're about to see, they haven't seen this kind of problem before. So, are you excited? So, how many apples do you see, and how did you count them? Even the grocery store can have that. Farmer's market. This isn't really fair to them, but this is how life works. I have an idea, Trevor? Okay.
first I counted one of them and just multiplied it by the second one and I got 36.
How did you count them? How did you know that they're, so you said you doubled it and got 36. So how many were in one tray?
18
And how did you know that?
because I counted it to bottom to top and also there's 3 rows of 3
Okay, so you saw 3 rows of 3.
and 4 rows of 4 and I just added 1 on the top.
Where did you see the 3 rows of 3?
In the middle, the second to bottom and
So you saw a
Third
row
to
of
top.
3 here. A row of 3 here. A row of 3 here. And a row of 3 here. And then you saw 4.
4 rows of 2.
4 rows of 2. So there's a row of 2, 2, 2, and 2. And then 1 on top. And so you got 18 and doubled it?
Yeah.
Did anybody count the same number but a different way?
What I did is group it all into 3s.
How did you see your 3s?
Yes. And then yeah, that's what I
How
said.
many groups of 3 did you see?
18. 5.
Grown-ups, are you seeing different patterns of the kids? Alright, your chatter.
So first I counted I counted the first one and then I got 18. So I knew the other one was 18, so I added 18 plus 18, which I got 36
Did you count them by ones, by twos?
by twos.
I did the same thing as some people, but I did 5 plus 5 plus 5 plus 3.
Where did you see your fives?
I did the same thing as Julian. I took 2 and 3, and I made 5, and then 5 times 3 is 15, plus 3 is 18.
That's another couple. I would say the best thing about the number talk is it gets lots and lots of kids involved. They can raise their hand up when they have one idea, they can connect with each other, they can build off each other's ideas. And I see a lot of flexibility in their thinking, and I see it transfer into really challenging problems that we come upon, because they're not afraid to try a lot of different variety of ways and listen to other people's ideas. And you'll even hear them weeks later say, remember that apple problem? And they saw the groups of 5, well, I see it like that. And so it's just a great way, and I'm lucky to have such great kids.